Imagine this. You're floating in the deepest void of space, far from any star, any galaxy. Nothing but endless blackness stretching in all directions. It's silent, motionless, infinite. But what if I told you this emptiness isn't really empty? What if, hidden beyond our sight, there exists an invisible force tearing the universe apart, and an equally mysterious substance holding it all together? These two cosmic enigmas, dark energy and dark matter, are the architects of reality, silently shaping the universe in ways we're only beginning to understand. They are locked in a relentless battle, a cosmic tug-of-war that determines the past, present, and ultimate fate of everything. But what are they? Where did they come from? And why do they matter? Before we dive headfirst into the greatest mysteries of the universe, a quick mission briefing. Every great journey starts with a few brave explorers. Right now, Cosmic Whispers is just beginning, and your support means everything. If you enjoy unraveling the secrets of the cosmos, hit subscribe. It's free, and it helps us grow this community together. All right, let's rewind time and travel back to an era when the universe was thought to be much simpler. For most of human history, we believed the cosmos was made of only the things we could see: stars, planets, gas clouds, and galaxies. Everything seemed to obey the familiar laws of physics. Gravity held celestial bodies in place, stars burned fuel to shine, and planets followed predictable orbits. But then, something unexpected happened. The deeper we looked into the cosmos, the more we realized that things weren't behaving as they should. Something was missing, something invisible, something powerful. The first major clue came in the 1930s, when Swiss astronomer Fritz Zwicky was studying a cluster of galaxies called the Coma Cluster. He expected to see galaxies moving at a certain speed, dictated by the amount of visible matter within them. But what he found was baffling. These galaxies were moving way too fast, as if an unseen force was holding them together. Based on the laws of physics, they should have been flung apart, drifting into the vast emptiness of space. The only explanation? There had to be an enormous invisible mass surrounding them, providing the extra gravity needed to keep them intact. He called it dunkle Materie, dark matter. But at the time, few took his idea seriously. Decades later, in the 1970s, an astronomer named Vera Rubin made an even more startling discovery. She studied the rotation of galaxies and found something strange. According to Newtonian physics, the stars at the edges of a galaxy should move slower than those near the center. Just like how planets orbiting the Sun follow Kepler's laws, Mercury, close to the Sun, moves fast, while Neptune, far away, moves much slower. But Rubin found that in galaxies, the outer stars weren't slowing down at all. In fact, they were moving just as fast as the stars near the center. That shouldn't have been possible unless something unseen, something far more massive than the stars themselves, was creating extra gravitational pull. The only explanation? A vast halo of invisible matter surrounding every galaxy, outweighing the stars themselves. This was the strongest evidence yet that dark matter was real, and not just real but everywhere. Scientists now estimate that dark matter makes up about 27% of the entire universe, and yet we still don't know what it is. It doesn't emit light, doesn't interact with normal matter in any obvious way, and passes straight through us without a trace. We know it's there because of its gravitational effects, but beyond that, it remains one of the greatest unsolved mysteries of physics. Some believe it's made of undiscovered subatomic particles, while others suggest more exotic explanations, like microscopic black holes or strange modifications to the laws of gravity themselves. But if dark matter is the glue holding the universe together, dark energy is its opposite, the force tearing it apart. And its discovery changed everything we thought we knew about the cosmos. For centuries, scientists assumed that gravity, the universal force of attraction, should be slowing down the universe's expansion over time. After all, everything with mass pulls on everything else. If you throw a ball into the air, gravity pulls it back down. The same principle applies on a cosmic scale. Galaxies should be pulling on one another, gradually slowing the universe's expansion. But in the late 1990s, two independent teams of astronomers made a discovery so shocking that it won them the Nobel Prize in Physics. They were studying distant supernovae, massive exploding stars that serve as cosmic mile markers, allowing scientists to measure the expansion of the universe. And what they found was astonishing. Instead of slowing down, the universe's expansion was actually speeding up. Something unknown, something vast and powerful, was accelerating the growth of space itself. This force, dark energy, makes up a staggering 68% of the universe. It is the single most dominant component of existence, yet it is utterly invisible and almost impossible to detect. It doesn't just push galaxies apart, it stretches the very fabric of space itself, making the universe bigger and bigger at an ever-increasing rate. If left unchecked, dark energy could eventually tear everything apart, leaving behind a cold, empty void in a future some physicists call the Big Rip. So, here we are. 95% of the universe is made of forces we can't see, can't touch, and barely understand. Dark matter keeps galaxies together, preventing them from flying apart. Dark energy pushes them away, accelerating the expansion of space. The two forces are locked in an eternal struggle, shaping everything we know. But how do they interact? Are they two sides of the same cosmic coin? Could dark matter and dark energy be different manifestations of the same hidden force? Or is the universe locked in a never-ending battle between attraction and repulsion? To answer these questions, we need to go deeper, into the very fabric of space and time itself. Picture this. You're in a spaceship, far beyond our galaxy, drifting silently through the cosmic void. Ahead, a brilliant spiral galaxy glows like a celestial whirlpool, its arms stretching out like frozen waves in an endless ocean. You watch as billions of stars orbit the galactic core, a dance choreographed by gravity itself. But then, something strange happens. The stars at the edges, far from the core, aren't slowing down. In fact, they're moving just as fast as the ones in the center. That shouldn't be possible. If gravity was the only force at play, those outer stars should be flung off into space, like a stone released from a slingshot. And yet, they stay locked in their orbits, as if held by an unseen hand. That hand, silent, invisible, and everywhere, is what we call dark matter. But if dark matter is everywhere, why can't we see it? Why can't we feel it? The answer lies in one of the most fundamental forces in nature: gravity. Unlike ordinary matter, dark matter doesn't interact with light. It doesn't reflect, absorb, or emit radiation. It's like a ghost, passing through the universe unseen, detectable only by its gravitational pull. And this gravitational pull is immense. It shapes galaxies, bends light, and even sculpts the large-scale structure of the cosmos. To truly understand dark matter, let's take a step further into the unknown, into one of the most powerful cosmic phenomena ever discovered: gravitational lensing. Imagine light as a traveler, moving in a straight line across the universe. Normally it should continue unbothered, like a ship sailing across calm waters. But when light passes near a massive object, like a galaxy or a cluster of galaxies, it bends, distorting like ripples on the surface of a pond. This effect was first predicted by Albert Einstein in his theory of general relativity, and it provides one of the strongest pieces of evidence for dark matter. How? Because sometimes we see galaxies bending light even when there's not enough visible mass to explain it. It's like looking at a funhouse mirror, where the reflection is warped, stretched, and duplicated. The only way this warping happens is if something invisible, something with mass, is bending the light. Scientists have mapped these distortions, and time again they reveal the same shocking truth. There is far more gravity present than what the visible matter alone can account for. In some clusters, as much as 80% of the mass is invisible. Dark matter is literally outweighing the stars themselves. But what is dark matter made of? That's where things get even stranger. Scientists believe dark matter isn't just ordinary matter, hidden in black holes or faint stars. Instead, it might be something entirely different, an exotic new type of particle. Some theories suggest it could be WIMPs, weakly interacting massive particles, hypothetical particles that barely interact with normal matter but have enough mass to explain the missing gravity. Others propose axions, ultralight, ghost-like particles that could subtly influence the way light behaves. And then there's a wild possibility that dark matter isn't made of particles at all, but rather a modification of gravity itself, a sign that our understanding of physics is incomplete. But while dark matter pulls the universe together, dark energy does the opposite. It pushes it apart. And to understand its terrifying power, we need to zoom out, beyond individual galaxies, beyond clusters of galaxies, to the very structure of the cosmos itself. For most of history, we believed that the universe was simply expanding, stretching outward after the Big Bang. Scientists assumed that gravity, the glue of the cosmos, would eventually slow this expansion down. Maybe if the universe had enough mass, gravity would win and everything would collapse in a fiery event known as the Big Crunch. But then, in the 1990s, astronomers looked at distant exploding stars, type Ia supernovae, which serve as cosmic mile markers, and discovered something shocking. Instead of slowing down, the universe's expansion was speeding up. Imagine throwing a ball into the air, expecting it to slow and fall back down, only to watch it accelerate upwards, faster and faster, until it disappears into the sky. That's what dark energy is doing to space. But what is dark energy? Unlike dark matter, which pulls with gravity, dark energy acts more like an anti-gravity force, driving space apart. Some scientists believe dark energy is a property of empty space itself, linked to something called the cosmological constant, an idea first introduced by Einstein. Others think it might be connected to an unknown energy field, one that permeates the entire universe. The real question is, how will this battle between dark energy and dark matter end? Will dark matter's gravitational pull keep galaxies together forever? Or will dark energy's relentless push eventually tear everything apart? If dark energy keeps accelerating, the universe might face a doomsday scenario known as the Big Rip, where galaxies, solar systems, planets, even atoms themselves are ripped apart by the ever-growing expansion of space. We are standing at the edge of the greatest cosmic mystery of all time. And yet, despite all our advancements, we still have no clear answers. The only thing we do know is that this cosmic tug-of-war between attraction and repulsion, between dark matter and dark energy, will decide the fate of the universe itself. But what if there's an even deeper connection between them? What if dark matter and dark energy aren't just separate forces, but different manifestations of the same hidden reality? Imagine standing at the edge of existence, gazing into the vast infinite fabric of space-time. On one side, dark matter, an invisible force pulling galaxies together, sculpting the cosmic web. On the other, dark energy, a mysterious presence, pushing everything apart, stretching space itself. Two forces, opposite in nature and yet bound in an eternal struggle. But what if they're not opposites at all? What if dark matter and dark energy are somehow linked, two sides of the same hidden force, whispering secrets about the true nature of the cosmos? For years, scientists have treated dark matter and dark energy as separate entities. Dark matter behaves like a silent guardian, holding galaxies together with its invisible gravity, while dark energy acts as a relentless expansion force driving the universe apart. But some physicists suspect these two enigmatic forces might be more connected than we ever imagined. And to explore this possibility, we need to rethink everything we think we know about the universe. One of the boldest ideas proposes that dark matter and dark energy aren't just related, they're actually part of the same underlying phenomenon. Some theories suggest that dark energy could be a kind of evolving dark matter, transforming over time. Imagine dark matter as an ancient cosmic structure, stable for billions of years, but gradually decaying into an energy-like form. As this decay process accelerates, it could explain why dark energy's effects seem to be growing stronger, pushing galaxies apart at an increasing rate. If true, this would mean that the very substance holding galaxies together today may one day be responsible for tearing them apart. Another radical theory links dark energy to something called quintessence, a hypothetical energy field that permeates space, changing over time. Unlike the cosmological constant, which assumes dark energy has always been the same, quintessence suggests that this mysterious force is dynamic, evolving, even interacting with dark matter in ways we don't yet understand. Some physicists believe that quintessence could be a kind of hidden fifth force, one that doesn't just passively stretch space, but actually influences the fundamental nature of reality itself. And then, there's the mind-bending possibility that dark matter and dark energy are not things at all, but simply illusions created by a deeper, unknown layer of physics. Some scientists have proposed that what we call dark matter might not be made of particles, but rather a strange effect of gravity itself, a sign that Einstein's equations are incomplete at cosmic scales. In this view, the reason galaxies behave so strangely isn't because of an invisible substance, but because gravity works differently than we thought. Could dark matter and dark energy be clues to an undiscovered law of physics, one that would revolutionize our understanding of space and time? To explore this idea, we need to take a detour into something truly mind-boggling: extra dimensions. What if our universe is just a slice of a much larger, multidimensional reality? Some theories suggest that dark matter could be ordinary matter, but in another dimension, one that we can't see or interact with directly. In this scenario, dark matter would be leaking its gravitational influence into our universe from a hidden higher dimensional space, creating the illusion of an invisible mass. And if dark matter is connected to extra dimensions, could dark energy be the result of those dimensions expanding, stretching our visible universe in ways we don't fully understand? These ideas may sound like science fiction, but they're grounded in real physics. Some of the most cutting-edge theories, like string theory, suggest that the universe might have more dimensions than the three of space and one of time that we experience. If true, then dark matter and dark energy could be the first glimpses of a much deeper hidden structure of the cosmos, one that extends beyond the limits of our perception. But the most unsettling possibility of all, what if dark energy and dark matter are simply byproducts of something even larger, something that exists outside our universe entirely? Some scientists have speculated that our universe might be part of a multiverse, a vast collection of parallel realities, each with different physical laws. If that's the case, dark energy could be a sign that our universe is interacting with another, unseen realm, perhaps even bleeding into it. And dark matter, it might be the residual gravitational imprint of another universe, overlapping with our own in ways we can't yet detect. The more we investigate dark matter and dark energy, the more questions arise. What if they're not just shaping the cosmos, but shaping time itself? Some researchers suggest that the acceleration of the universe's expansion might not be due to dark energy at all, but rather a shift in how time flows on a cosmic scale. Could the passage of time itself be changing, stretching space as a consequence? If so, we may need an entirely new framework for understanding reality. Right now, we stand at the edge of knowledge, peering into the abyss of the unknown. Dark matter holds the galaxies together, dark energy pushes them apart, and somewhere in between lies the answer to the greatest mystery of all: what is the true nature of the universe? But there's one final chilling question that remains. If dark energy continues to accelerate the expansion of space, what does that mean for the future of the universe? Will galaxies drift so far apart that the sky becomes empty? Will stars burn out, leaving only a frozen void? Or could dark energy itself one day collapse, triggering a cosmic event that resets reality? Now, imagine standing at the edge of the universe once again, but this time the view is different. Instead of the bright, swirling galaxies, the night sky is becoming emptier. Stars are dimming, galaxies are drifting apart, and the vastness of space seems to stretch infinitely, far beyond what we ever imagined. You can almost feel the pull of something unsettling in the distance. This is the future of the universe, and it's a future shaped by dark energy and dark matter. But what does this future hold? Will the cosmic tug-of-war between these two forces determine the ultimate fate of everything? We've already seen how dark matter and dark energy shape the universe's present. Dark matter binds galaxies together, preventing them from flying apart. It's the unseen scaffolding that holds the cosmic web intact. Meanwhile, dark energy drives the accelerated expansion of the universe, pushing galaxies further and further away from each other. But these forces don't just define the here and now. They're the architects of the universe's future. So what happens next? Will the universe continue expanding forever, growing colder and emptier until everything is scattered across a dark, featureless void? Or could the dark energy that's accelerating the expansion eventually turn on itself, reversing the cosmic tide and pulling everything back together in a fiery collapse? To understand these possible futures, we need to examine the ultimate consequences of the cosmic tug-of-war. The most widely accepted scenario today is the idea that the universe will continue expanding at an accelerating rate, driven by dark energy. This scenario is known as the heat death of the universe. Over the next trillions of years, galaxies will move farther and farther apart. Stars will burn out, their nuclear fuel running dry. The black holes left behind will slowly evaporate through a process known as Hawking radiation, eventually leaving only dark, cold remnants of what was once a thriving cosmos. As the universe expands, it will approach a state of absolute thermodynamic equilibrium. In this state, energy is evenly spread out and no more work can be done. The universe will become a vast, empty, frozen wasteland, dark, cold, and lifeless. If dark energy continues to dominate, this future is inevitable. And yet, even in the cold emptiness, some questions remain. Is this the final end of the universe? Could there be something deeper, something beyond the reach of dark energy itself? Enter the possibility of a big rip. This is a more dramatic and perhaps more unsettling future. In this scenario, dark energy doesn't just continue pushing the universe apart at an accelerating rate, it grows stronger. The more the universe expands, the more dark energy increases its power, ripping apart the very fabric of space itself. Galaxies, stars, planets, even atoms will be torn apart, their bonds shattered by the ever-expanding force of dark energy. The end would come in a fiery, violent cataclysm, with every corner of the universe ultimately unraveling. It's a scenario of utter cosmic destruction. But could there be an even more profound fate? What if dark energy itself doesn't just drive the expansion? It could be a sign of something deeper at play, something we don't yet understand. Some scientists speculate that dark energy could eventually weaken, possibly collapsing into a singularity, triggering an event known as the Big Crunch. This would be the opposite of the Big Rip, a scenario in which gravity finally wins and the universe collapses in on itself, compressing all of its matter and energy into a singular point. From this point, the entire cycle of the universe could begin again, perhaps giving birth to a new cosmos in a never-ending cycle of creation and destruction. This idea, known as cyclic cosmology, suggests that our universe might be one of many, each one being born, evolving, and ultimately dying in a cycle that stretches back to the beginning of time itself. If dark energy eventually recedes, it could give way to a new phase of contraction, leading to a new Big Bang. In this way, dark matter and dark energy might not just be forces of destruction, they could be part of an endless, cyclical dance that keeps the universe in motion, forever renewing itself. But even with these mind-bending possibilities, one thing remains clear. Dark energy and dark matter are the ultimate shapers of the universe's fate. The battle between them, the struggle between attraction and repulsion, has already set the stage for the cosmic drama of the future. It's as though the universe is engaged in a grand experiment, one whose outcome we can't predict. Will the universe continue expanding indefinitely, fading into nothingness? Or will it implode in a fiery rebirth? And then there's the deeper question. If dark matter and dark energy are not just separate forces, but linked in ways we haven't yet discovered, what does that say about the very nature of reality itself? Could these forces be guiding us to a new understanding of physics, unlocking doors to realms beyond our comprehension? Are we on the cusp of discovering a hidden connection between matter, energy, and time, one that could change everything we know about the cosmos? The universe we know is a place of incredible mystery, a place where dark forces, dark matter and dark energy, shape the past, present, and future of everything. But we are only scratching the surface. As we continue to study these forces, one thing is certain: we are on the brink of uncovering the greatest secret of all, what lies at the heart of the cosmos. But what do you think? Is the universe doomed to an endless expansion, growing colder and emptier with each passing moment? Or will dark energy eventually collapse in on itself, bringing the cosmos to a fiery end? Let us know your thoughts in the comments below. If you found this exploration of the cosmos as mind-blowing as we did, don't forget to like, share, and comment. What do you think the future holds for our universe? Is there hope for something beyond the dark, cold emptiness? Let's keep this conversation going and continue unraveling the mysteries of the universe together.